Hi, I'm Alan, and I will show you the process of porting the Armored Car game to the MiSTer platform from MiST. Ports from the MiST platform generally follow these steps. We will start with the pacman core, since it has the most up-to-date system files. We will adapt it for Armored Car, set up the clocks, compile it, and test it. After this video, we will have a core that runs, but it can't be distributed because the ROMs are hard-coded into the RBF. I navigated to the source code on MiST and downloaded it to my computer. Next, I download pacman. I copy pacman and rename it Armored Car. There are a bunch of different places to rename, including the file names and inside the QPF file. We can delete the RTL and releases folder from pacman. We should also delete the .git folder so that it's no longer pacman. Open the Armored Car QSF file and scroll down until you find the Verilog and VHDL files. Copy these files into our files.qip file in the pacman project. We want to substitute our top-level system Verilog file instead of the MiST one. In the MiSTer, the files.qip is separate and it's included in the QSF so that when you update the framework, you can simply replace the QSF file with a new one and rename it. The sys folder includes the standard framework files with the exception of the PLL. The PLL is in the system folder, but it is specific for each core. It contains the clock frequencies that the core requires. There is a lot of information in the top-level MiST Verilog file that we will need, including how to call the main simulation, clock information, keys, and more. We notice that in addition to a clock_sys, there is a clock driver that generates the clocks needed for this core. We are going to copy this chunk of code into our old pacman top-level file. We need to find out what speed the clock_sys is. I like to comment the code and put the frequency next to the lines to make it clear. Remove the old clock divider. Open the Armored Car PLL file and find the clock frequency. The clock is a little more than 24.5. We will also need a clock double that, around 49. The new direct video system requires clocks greater than 40 MHz. In Quartus, switch to the IP components view and right-click to edit the PLL. Always put the highest clock speeds first. Create two entries, one for around 49 and one for the 24.5 clock. Save the settings and we will update the top-level Verilog file. Change the core name from Pacman to Armored Car. Copy the Armored Car calling block from the MiST top level and paste it in. Change some of the signal names to match the MiSTer file. Remove the old pacman block. There is a lot more we need to clean up in the top level code. We need to remove a bunch of the multi-core pacman support dips settings and other things, or adapt them for our core, but we'll leave that as an exercise to the viewer. Oops, it doesn't compile. Let's change the video block to create a clock divider for the pixel clock. Check the size of the RGB variables. They are 3 bits wide for the Armored Car. We need to adjust the video block. They were a different size in the pacman core. Oops, we included the MiST PLL file in our files.qip. Let's remove that and try again. Wow, after only 7 minutes, it compiled. Now, let's see if it runs. That's incredible. We actually have video and sound. Very exciting day.